Hi, myself Anagha K, Assistant Professor, Department of Microbiology, KSR College of Arts and Science for Women, Tirchangot. Today, let's discuss the topic Antigen Antibody Interaction from the course Immunology and Immunotechnology. Before discussing antigen antibody interaction, let's see what is antigen, what is antibody. Antigen is any foreign substances that when entering our body sometimes self-elicit a series of immune response and are then precisely known as immunogens, whereas some of them don't directly elicit an immune response but require the help of some other molecules like a carrier protein to do so, and these are called as hapten, and these all are collectively known as antigens. Okay, now let's see what is antibody. Antibody is simply a component that is produced by the immune system in response to an antibody, that is in response to a foreign invader. So basically antigens are the generators of the antibodies and they interact to produce immune responses. Antigen-antibody interactions are certain biochemical reactions between the antibodies and specific antigen when they come closer to a distance of several nanometers. It is binding of a paratope of antibody to specific antigen on either epitopes, or that is initiates a series of immunological responses to act against a respective antigen for the removal or destruction. Thus, antibody reacts with antigen to form an antibody-antigen complex, and this leads to immune response. And these reactions are highly specific, and antigen reacts only with antibodies producing by itself or closely related antigens. Antibodies recognize the molecular shapes of the antigen and better the fit of the epitopes, that is in terms of geometry and chemical characters to the antibody combining sites, the more favorable the interactions that will be formed between the antibody and the antigen, and the higher affinity of the antibodies for the antigen. There are certain properties of the antigen-antibody interactions. These antigen antibody interactions are highly specific reactions, as I mentioned before. It will occur in an observable manner, and thus these leads to non-covalent interactions, that is van der Waals force, ionic bonds, hydrogen bonds and hydrophobic reactions occurs. And no denaturation of the antibodies and antigen occurs. This is reversible. Affinity, it is the strength with which one antigen binds to a single antigen binding site on the antibody. Whereas avidity, it is the broader term than the affinity. It measures the overall strength of the antibody-antigen complex, and it depends on various factors like the affinity of the antibody, valency, that is the number of antibody sites present in the antibody and the antigen, and the structural arrangements of the epitopes and the paratopes. The other property is cross-reactivity, and it refers to the ability of an antibody to bind to a similar epitopes of the different antigens. So for this antibody-antigen interaction, there occurs two stages. First one is primary stage and second one is secondary stage. In primary stage, it is the initial interaction between the antibodies and antigens, and these are irreversible, rapid and without any visual effects. Whereas the secondary stage, it is the irreversible reaction between the antigen and antibodies, and thus it will be slow, visible, and this will be with visible effects. There are many factors which affects the antibody-antigen interactions, and these effects include temperature, pH, ionic strength, enzyme treatment, concentration of the antibody and antigen involved, and the number of antigen binding sites in the antibody, and the structural arrangements. So let's see one by one. Temperature, it depends on the chemical nature of the epitope, paratopes and bond involved. That is, hydrogen bonds are more stable at the low temperature, whereas the hydrophobic bonds are stable at the higher temperature. pH and the optimal pH for an antigen antibody interaction is seen to be 6.5 to 8.5 range, and the extreme pH value changes will change the conformation of the antibodies and inhibit the reactions. Ionic strength. The effect of the ionic is important in blood group serology. Here, the reaction is significantly influenced by the sodium and chloride ions in normal saline, that is Na plus and Cl minus, clusters around the complex and partially neutralize the changes, potentially inferring the antibody binding to the antigen. This could be problematic when low affinity antibodies are induced. Enzyme treatment. Many proteolytic enzymes are used to enhance the reactions, and some of these which we are commonly used is papain, ficin and bromelain. Concentration of the antigen and antibody. With the increase in concentration of antibodies and antigen, then these will enhance the reaction also. Number of antigen binding sites. More the number of antigen binding sites of the antibody, more the interaction will occur between the antigen and antibody. Structural arrangement. If the structure of the epitope and paratope is such that they could fit well as a lock and key, then it will enhance the interactions. Many chemical bonds are responsible for the antigen and antibody interactions. Those chemical bonds are electrostatic bonds, hydrogen bonds, hydrophobic interactions, and van der Waals bonds, as we have discussed earlier. There are different types of antigen antibody interactions, and these are classified into two: in vivo and in vitro. In vivo, that is, it will occur in the natural conditions, and these include general antibody mediated immune response occurring in our body against any antigen, and these includes agglutination, precipitation, complement fixation, neutralization, AB dependent cell mediated toxicity, immobilization, and opsonization. Whereas in vitro, it is done artificial condition. It is done in artificial condition, that is, it includes a series of serological tests performed in laboratory to detect the interaction between an antibody and antigen in many cases of diseases. And it also includes in agglutination, precipitation, complement fixation, and neutralization. Let's see all these interaction types of antigen antibody interactions one by one. Precipitation. Precipitation reaction occurs between the soluble antigen, that is, small antigens and soluble antibodies form an insoluble precipitate, that is, soluble antigen and soluble antibodies will form an insoluble precipitate, and these will be seen as a settlement in the reaction after the reaction in the solution. The proportion of antigen and antibody in the reaction must be equivalent for this reaction to occur, and this occurs in the presence of electrolytes at a specific pH and temperature. Antibodies involved in these are called precipitants, and there are two types, that is, in a solution where flocculation or ring test can be done. In agar, immunodiffusion, and in agar with electrostatic field, immunoelectrophoresis is done to detect these precipitation. Agglutination reaction. The reaction between insoluble, that is, large antigens and soluble antibodies leads to agglutination. Here, antigen is large in size and is also insoluble, and these will lead to the formation of visible clumps, and these will occur on the surface of the particle involved. Antibodies involved in these reactions are called agglutins, and the types include direct or active, that is, using slide tube we can do the test, and it is also known as Coombs test or agglutination test. Whereas the passive, that is, lattice hemoagglutination and coagulation test can be done. This picture shows the reactions. Complement fixation. It is the process of the binding or fixing the serum component proteins with antigen antibody complex, which further initiates a series of immune response against the antigen. It is used in the detection of specific antigen or antibody in a patient's serum. And the reagents required are antigen, antibody, complement and indicator system. And the common complementary fixation test is known as Wassermann's test. It is used for the detection of Staphylococcus, which is a Streptococcus species. Here the two examples are given. Thank you.